It is January 2026. If you've been offline for, I don't know, the last few weeks, maybe on a digital detox, you might want to sit down for this.
Yeah.
Seriously. Just think about where the industry was maybe 2 months ago. We all thought the dust had finally settled. The big Western labs, OpenAI, Anthropic, Google had rolled out their latest heavy hitters. We were all getting comfortable, figuring out the prompting strategies for GPT 5.2 or how to fit Claude 4.5 Opus into our workflows.
And then the whole board gets flipped.
Completely flipped.
It really just speaks to the relentless velocity of this space. Just when you think the market is stable, you think you know the players.
A massive contender just enters the arena.
And this time, what's fascinating is where it's coming from. This isn't San Francisco or Seattle or London.
No, it is not. Today, we are diving into a huge new release from China that is probably causing some serious headaches in a few Silicon Valley boardrooms. We are looking at Kimi K2.5, a new open source model from a company called Moonshot AI.
And right off the bat, we should probably address the elephant in the room.
Yeah. Usually when we talk about non-Western models, there's this lingering assumption that they're fast followers.
Right. Good tech, solid, but usually a generation behind whatever Sam Altman just put on stage.
Exactly. You get a model that's kind of like GPT-4, about a year after GPT-4 actually came out.
But Kimi K2.5 it's breaking that pattern.
Yeah.
This is not a copycat. This is a company with a valuation heading towards, what, $4.8 billion?
Around there, yeah.
And it's led by some of the most rigorous academic minds in the field. They're claiming they haven't just caught up, they've introduced a whole new architecture for how AI agents work.
And that's the agent swarm idea we're going to get into today.
Exactly.
Looking at the research, that seems to be the key differentiator. We're not just talking about a better chatbot. We're talking about a fundamental shift from a smart assistant to a coordinated workforce.
Yes. But to really get why this swarm architecture is credible and not just marketing hype, we have to look at the pedigree. You have to look at who's building it.
The architect behind the machine.
You really can't understand the machine without him. We need to talk about Zhilin Yang.
I was looking into his background, and calling him a heavyweight feels like an understatement.
Oh, yeah.
He is not your typical startup founder who dropped out of college.
Yeah.
This guy is. Well, he's basically AI royalty.
He is. Before Moonshot, he was deep inside Google Brain and Meta AI. But his real claim to fame, the thing that makes people in the field sit up and listen, is his publication record.
He co-authored Transformer XL and XLNet.
Yes. And if you're a machine learning engineer, you know those names.
Okay, let's pause there for a second. Transformer XL and XLNet, they're legendary papers, but for you listening at home who isn't reading ArcSIF preprints over coffee, why do those papers matter so much?
That's a great question. So before those papers, transformer models, the T in GPT, were actually pretty bad at remembering things over long distances. They had a really fixed, short attention span.
So you give it a long document, and by the end, it's forgotten the beginning.
Exactly. It just loses the plot. Transformer XL, it basically taught models how to handle much longer sequences of data. It introduced a mechanism for recurrence, letting the model carry context forward.
So in a way, he's one of the grandfathers of the long context window that we all just take for granted now.
Precisely.
He built the foundation that lets these models read entire books instead of just a few paragraphs.
He helped architect the ability for LLMs to read entire code repositories or, massive legal contracts. So when he says he's building a model focused on lossless long context, it's not just a feature request he gave an engineer.
It's his life's work.
It is.
Okay, so he's at the absolute top of his game in the US. Then 2023 hits. ChatGPT has its iPhone moment. What makes a guy like that leave and go back to China?
Opportunity and ambition. He saw the generative AI explosion and realized the whole playing field was resetting. So he went back, gathered 3 former colleagues from Tsinghua University.
Which is like poaching the top department heads from MIT for context.
It is, and founded Moonshot.
I have to say, Moonshot is a bold name. You can't call your company Moonshot and then deliver, a mediocre calculator app.
True, but there's a really poetic nuance to it. In Chinese, the company name translates to the dark side of the moon.
Oh, that's fantastic. Very Pink Floyd.
It implies going somewhere uncharted, somewhere no one else has reached yet. It's about exploring the unknown.
And the model name, Kimi.
That's just Zhilin Yang's English nickname.
That's a fascinating contrast. You have this grand, mysterious identity, the dark side of the moon, and the product is just named after the guy in charge.
It's a mix of vision and confidence, right? And make no mistake, his goal is AGI, artificial general intelligence. He's been really clear he isn't interested in trendy consumer apps. He wants to build a self-improving architecture.
Self-improving. Okay, let's put a pin in that because the implications of that are, well, they're huge. But let's get into the nuts and bolts of Kimi K2.5 first. What's actually under the hood?
It's a monster. Kimi K2.5 is built on a mixture of experts, or MOE architecture.
Okay, that's becoming the standard for these big frontier models.
It is, but they've scaled it aggressively. We're looking at 1 trillion total parameters.
1 trillion parameters. That puts it right up there with the biggest models rumored to be at OpenAI or Google.
It does.
But mixture of experts is a term that gets thrown around a lot. How should we visualize that? Is it just one giant brain?
No, and that's the key to its efficiency. Think of an old, dense model, like a general practitioner who has to know everything about everything.
Right.
So every time you ask a question, the whole brain has to light up. That's slow, and it's expensive.
You don't need a cardiologist to tell you how to boil an egg. It's a waste of resources.
Exactly right. The MOE model is like a massive hospital filled with specialized departments. There's a gatekeeper or a router, like a front desk. You ask your question, and the router sends it specifically to the experts who know that topic. So even though Kimi has 1 trillion parameters total,
It only uses a fraction of them at any one time.
right, it only activates about 32 billion per inference, per thought.
That's a massive difference. You have the knowledge base of 1 trillion parameters, but the speed and cost of a 30 billion parameter model.
That's the magic. It lets them be incredibly nimble. And they built on their previous model, feeding it 15 trillion mixed tokens.
Mixed tokens, so that's not just text from Wikipedia.
Correct. It was ingesting text and vision simultaneously. This is crucial for what they call native multimodality,
And it has a massive context window on top of that, 256,000 tokens.
which, thanks to Yang's background, is native to the architecture.
Just to put that in perspective for everyone, that's like holding 3 or 4 average-sized novels in memory at the same time.
Or an entire code base. And because they're releasing this with a modified MIT license and super aggressive API pricing, they're basically handing this massive capability to developers for pennies compared to the incumbents.
It's the classic disruptor playbook. Undercut on price, over-deliver on specs. But I want to drill down on that native multimodality piece. What makes Kimi different?
The difference is integration. In older systems, if you showed an AI an image, a separate, smaller AI would basically write a text description of it and then feed that text to the main brain.
And something gets lost in translation.
Always. It's like describing a painting over the phone versus just letting someone see it. Kimi processes the visual data, the actual pixels, as native tokens, just like they were words.
So it sees the image in the same way it reads a sentence.
Exactly. It uses what's called spatial temporal compression to understand visual features. And this is why its coding with vision capability is making such waves. It doesn't just see a static screenshot, it understands flow.
I saw that demo. Someone recorded their screen just clicking around a website, scrolling, showing the hover states on buttons.
Opening menus.
Yeah. And they uploaded that video and just said, build this.
And it did. That's the viral example. It generated the front-end code, the CSS, the animations, everything just from watching the video. It captured the user experience, not just the static layout.
That feels like a huge leap. Usually you have to describe everything. Make the button turn blue on hover. Kimi just watched and understood.
It's closing the gap between design and engineering. And they've packaged this into Kimi Code, a plugin for V's Code, Cursor, and Zed. They are clearly aiming to eat the market share of tools like GitHub Copilot.
But with this visual dominance as the main selling point.
For sure.
Okay, so we've got a giant brain that can see and code. But the thing that really stood out, the thing that sounds the most sci-fi, is the agent swarm.
This is the real paradigm shift.
Swarm implies, well, a lot of things. Bees, drones. What does it mean for an LLM?
Okay, so think about how we use AI agents right now. You give an agent a task, build me a snake game.
Right.
It writes the code, maybe checks it, maybe fixes an error. It's a linear process, one freelancer working through a checklist.
A serial process. Step A, then step B. If B fails, C never happens.
Exactly. Moonshot has introduced a parallel agent reinforcement learning architecture. So instead of one freelancer, you spin up a swarm of up to 100 sub-agents.
100 agents on the same prompt.
Simultaneously. And they're not all doing the same thing. The orchestrator, the central intelligence, it breaks your request down. So suddenly you have Agent A reviewing documentation for a library you want to use.
While Agent B is drafting the database schema.
Agent C is writing the front end, and Agent D is actually looking at screenshots of the output to visually debug it.
And they're all communicating.
Yes. They can execute up to 1,500 tool calls at the same time.
That sounds incredible, but also chaotic. It reminds me of the mythical man-month problem. Adding more people just makes the project later because of the communication overhead.
And that's where the reinforcement learning part comes in. The orchestrator has been trained specifically to manage that chaos. Moonshot claims this reduces execution time for complex tasks by 4.5 times.
So it's the difference between one guy building a house and a coordinated construction crew with a foreman who actually knows what they're doing.
That's the perfect analogy. And for you, the user, it changes the prompt. You stop asking, write this function, and start asking, manage this project. It moves the AI from a tool to a workforce.
That has to be expensive, though. Running 100 agents must burn through tokens.
It does, which is why they have different modes. There's instant for quick chats, thinking mode for deep reasoning, agent mode for a single task, and then the agent swarm.
You wouldn't use the swarm to ask about the weather.
No, you use it for high-value, complex workflows where the cost of compute is still way cheaper than hiring a human team to do the same thing.
So let's talk performance. Claims are easy. Does the rubber meet the road? How does Kimi K2.5 actually stack up against, say, GPT 5.2?
The benchmarks are surprisingly strong. On coding, specifically the W bench tests, Kimi K2.5 actually beats GPT 5.2.
Beats GPT 5.2 in coding. That's the gold standard right now. That's a serious claim.
It is. And in the video MMU benchmark, which is for video understanding, it beats both GPT 5.2 and Claude Opus 4.5.
Which validates their whole native multimodality approach.
Right. If it were just converting video to text, it wouldn't score that high.
What about general reasoning? I know there's that new benchmark everyone is terrified of, Humanities Last Exam, or HLE.
Right, HLE. That test is designed to be brutal. Kimi K2.5 scored 51.8% on text and almost 40% on images when it was allowed to use tools.
51% sounds, to a layperson, that sounds like a failing grade.
Context is everything. Most previous models score in the single digits on HLE. Getting over 50% is remarkably high for a test designed to be human expert hard.
This feels like a geopolitical turning point. For a while, the narrative has been that regulations and chip bans would keep Chinese AI permanently behind.
It absolutely challenges that Silicon Valley supremacy narrative. Moonshot is backed by Alibaba and Tencent. They have deep pockets. But more importantly, they're showing that architectural innovation like how you build the swarm matters just as much as raw compute.
You can be more efficient with the chips you have.
Exactly.
I do want to circle back to the swarm concept, though, because I can see some risks. We've all seen an AI hallucinate. If you have 100 agents, you just get 100 times the hallucinations.
That is the stability risk. The nightmare scenario is what's called a coordinated hallucination.
Okay.
Imagine Agent A makes a mistake. Agent B, instead of catching it, assumes Agent A is correct and builds on it. Agent C validates it because it aligns with Agent B.
And suddenly the whole swarm has peer-reviewed a lie into existence.
That's it. It's grouped into the speed of light. A single agent might doubt itself. A swarm can reinforce its own bias.
Terrifying.
Moonshot says their orchestrator is trained to prevent this, to act as a critic, but until we see it deployed at scale in the wild, we don't know for sure.
And then there's the scalability. If everyone starts spinning up swarms of 100 agents, the energy consumption must be astronomical.
It's a valid concern.
Yeah.
But the goal is efficiency. If a swarm can finish a task in 5 minutes, that would take a single agent 2 hours of trial and error.
The swarm might actually be more energy efficient per task.
It could be. It's not about cost per second. It's about cost per outcome.
That's a fair point.
And this competition is ultimately good news for you, for the listener. The fact that Moonshot exists forces OpenAI and Anthropic to push harder. It drives down prices. It accelerates features. The tools on your desktop in 2026 are going to be vastly more powerful because this race is happening.
So to wrap this all up, we have a former Google and Meta wizard who goes back to China to explore the dark side of the moon. He builds a trillion-parameter model that uses a team of experts to be efficient. It can watch videos to build apps, and it can deploy swarms of 100 agents to act like a coordinated workforce.
And it's doing all of this while beating, or at least matching, the best models from the West on key benchmarks. It's a very loud wake-up call.
It is a lot to process, but I want to leave everyone listening with one last thought, something that stuck with me from Jilin Yang's own writing.
You're thinking about the self-improvement angle.
Exactly. Yang said that the current way we train AI with human feedback, fine-tuning, that's all just temporary, his stated goal is an architecture that improves itself.
The ultimate recursive loop.
So the question is, if the swarm can code and the swarm can reason, and the swarm can critique its own work. Are we looking at the last generation of AI that needs human engineers? What happens when the swarm is tasked not with building an app, but with building the next version of Kimi?
That is the multi-billion-dollar question. And looking at K2.5, we might be a lot closer to the answer than we think.
Something to mull over while you update your drivers.
Yeah.
Thanks for joining us on this deep dive. We'll catch you on the next one.